Alright guys, so here's my setup right now. This originally was a temporary solution to a problem. I needed real accurate cutting in that, or real accurate turning in that direction, so I wasn't getting that out of my dial, so I kind of just cobbled this up. And it's probably been on there for 3 or 4 years now, and I have never had a problem with it, so I just kept using it. Obviously it's a caliper that's been cut down and just kind of modified to work on there. And it works like that. But it's now stopped working. You know, it was like 10 bucks for the thing, so I think getting 3 or 4 years of use out of it's pretty good. So I'm gonna clean this up, take this one off, and see what we need to do to put the new one on. Alright, just in case somebody else wants to do one of these like this, it's basically just a caliper. Well, it is just a caliper, and you got an attachment point here, an attachment point here. This is the moving attachment point. This stays the same in this case. You could do it either way, but in this case that's how it works. And these two cap head screws right here are actually just a guide. They're fitted just to hold that from moving up and down or twisting. And once that's all mounted together, like I said, it worked pretty well. It's not optimal, but see, this is just free floating there, so when it moves like that. I'm not holding it very well, but you get the idea. This probably took me an hour or so to put together. The worst part of this was grinding off. These are hardened. It says stainless hardened, and they were stainless hardened. You could not drill them. I had to grind them off. And one other thing too before we get started, and I don't know if I've ever actually showed this piece before. This is a riser that I made out of a chunk of aluminum. This was, you see the rough aluminum here, that's how I got it. It was just a big block, and all the machining you see done on here was all done on this machine. This is one of the larger pieces I've ever milled on. I did the dovetails on this machine. I fly cut the top, of course countersunk the mounting holes, drilled those through, and I fly cut the bottom. And all that was done on this machine, so it can do some work. Alright guys, I've been doing a lot of thinking. Sorry about that. I've been doing a lot of thinking here, and it's usually not the best thing to do, but I'm going to put it on this side of the cross slide. Two big reasons for that. The first is to put it on this side because it's much bigger than what I had on there before. I run into the problem here. This point right here is where you lock down the cross slide. I have to have that. This machine, you know, is not the most rigid, and it needs it needs some pressure on the cross slide when you're doing lathe operations, and it definitely needs to be nearly locked down when you're doing mill operations. So the problem I'm having is that to do that on this side and leave that space open, because this is much bigger, the reed head has to move with the top of the slide. So it has to be in a fixed position on the top of the slide so I can always access that lock. Otherwise, if it was sliding, it would slide over that lock, and then at some point I wouldn't have access to it. So it's only one way it can go in that regard. Now that presents a little bit of mounting issues because I can't go lower, so I would have to mount it with like a flat plate that comes from it over back or around the corner here. That that could be worked out. It's not a big deal. So, but the next big deal is I've taken the tailstock off, but the tailstock. I got very limited travel. I only have about 3 or 4 inches on the tailstock, and I've already run into problems with the other one that I needed the tailstock to come farther against the cross slide. So I'm losing even more space that way. So that moves me to the other side. Now, the other side presents 2 challenges as far as I'm concerned. The first is that means that the whole slide has to be covered a lot better because it's going to get a lot more swarf down on it. If you have some other suggestions, please put them in the comments. My plan right now in my head is to take some like aluminum flashing and bend it into basically a U shape so it wraps around the whole thing and would cover the whole thing. Still not optimal because swarf builds up, you know, in the bottom of the bed here because there's no holes through like a lot of lathes have to let that stuff drop through, and it could get pushed up under that that cover. Another option is to build maybe like an accordion. You've seen these things, accordion covers. It's like a cover that folds up and folds out as you move to cover from here to here, and that would keep any swarf from going down to the lathe bed, which would actually be a better thing anyway. Now I do try to keep this area clean, but you know, as you know, when you're doing multiple operations over a time, you forget. That's the first problem with putting it up front, and that's probably the biggest issue. I don't have any locks on this side, so I don't have anything to worry about that way. That means that I can make the reed head stationary and just the rod will move. Just the linear scale will move. That works out better because it's less wear and tear on the wires. The wiring is easier. But the second issue is when this cross slide, let me move it up there to show you. Okay, that's as far as it goes forward. It doesn't go any farther to the headstock than that. Now, that means that this is my gap. So I'm going to lose maybe 5 millimeters, 10 millimeters here with this being down in there. Not a problem for milling, or not a problem for lathe work, because my cutter is usually, you know, right here, so I wouldn't be cutting into the chuck. I wouldn't be cutting that far into the chuck. So that's not an issue, but the mill head, on the other hand, swing the mill around, back you up a little bit. So now I'm right, you know, basically at the edge of the table here. I don't think that that's going to be a big issue either, actually. The more I think about it, I don't normally, I think I've only one time have run out of space here, and what I did was because I put another compound table on here that actually has movement as well. I can actually move it and get it in position over this if I have something that's a little bit too big. So not a big deal there. Push that back out of the way. So that's my rationale for doing it that way. It's one, an easier installation, and 2, I get more room for the tailstock to come up, you know, flush against the compound. The big challenge is keeping crap out of it. Now, it still gets crap back here anyway. That's why that other one died. So, you know, it still should have a cover back here, but it's more likely to get more stuff up here. So love it or hate it, that's what I'm going to go with. When I bought this, I didn't really consider that it was so much thicker and bigger than the original thing I was using, but you know, this part is wider, this is thicker, you know, it's just a whole bunch of little things to deal with. So that's how I'm going to mount it. You know, if it doesn't work, if I find it to be a pain in the ass, I can just, you know, I'll redo it. So let's get to making some brackets, because I'm going to have to do a couple special brackets here. Okay, so I've cut down about 10 millimeters off of this thing, off the linear scale, and we're going to attempt to do a little test run here. I'm going to hold it. See that? Yeah. I'm going to hold it where it goes and where the reader is going to sit. I'm going to hold the reader and let the scale wind out. See what happens. 0. And right there is the maximum setting. Just make some spacers to go between that bracket and this piece, between this bracket and this piece. These brackets are almost exactly the same width as this, but I'm going to take a little bit off each bracket just so I'm not so tight on there, because I want it, you know, less than flush up here. I don't want anything to interfere with the top of the cross slide. Looks to me like I'm already running pretty straight. Yeah, that's within a half a thousandth. That's plenty fine. I also don't need to remove the chuck in this case. My part is small enough that if I put it on the edge of the vise here, I got plenty of room to work without removing the chuck. It just saves me some time. So I'm just going to square up this block. Did you see that? Guess I had him out too far. Now, you'll probably see the chuck moving. That's just from vibration. See, the cutter's not moving when I move the chuck. It's out of gear. It just sometimes it vibrates, and that causes it to look like it's moving. No big deal. Alright, let me tighten a few things up and we'll get going. I guess you just saw the head move off the piece. That was an accident on my part. I did not tighten up the swing arm, the swing head. So let's try that again. Just going to break these edges a little bit so I don't cut my hand. Now I'm not going for ultra square on here. I'm just cleaning it up basically. Alright, I about did a mess up there. I need to set my, this is going to be 21.4, so I need to set my depth here. And what I'm going to do is I'm just going to run this down, run my cutter down till it's level with that parallel underneath, till this touches it. I'm going to zero my quill DRO and bring it back up to 21.4. And then hopefully we'll just be able to take this in one cut. That'll be good right there. Lock my quill down so it's at the right depth. Alright, now normally I wouldn't take this big a cut, but let's try it just out of curiosity. It's about 3/16 of an inch, so what is that? That's oh, I don't know what it is. Let's try a 3/16 cut on this thing. It's a big cut, and it's probably not going to do it, but we'll try it. I'm going to do about half the cutter here. Not a problem. Not at all. I don't know why I didn't think that that would work. .41 is what I'm getting. That's exactly what I wanted. 4.2 on that side, maybe 4.3. That's plenty close enough for my work. If we got it within 1/10 of a millimeter, that's fine. Okay, so I want to make this measurement 40 millimeters. So let's side mill it. We're going to put it on the good sides, the sides that I'm going to clean up one side and then take it down on the other side. Okay, so I got my block turned around. All I'm going to do here, and actually I've already done this, but I forgot to turn the camera on, so I'll put my calipers on approximately 40 millimeters. I don't want to go over 40, but anything around 40, under 40 is fine. It's not a critical measurement. And I'm just going to give myself a reference. I'm just going to scribe a line right there at my depth, and I'm just going to cut to that line, and I'm going to take the line, so I know that if I take the line I'm 40 or under. So let's see how much of a cut that is. I'm just going to take a light cut to begin with, and each time I take one of these cuts I'm tightening up the gibs on the cross slide and the x-axis, the length side, and the axis that I'm moving, I'm tightening it down to just so that I can easily move it, so that there's no rocking or no backlash in it. Alright, that looks good. Let's try a cut there. Alright, that was a puny cut. Let's try a little more. You know what I'm just thinking about? I think I'm going to increase the speed a little bit. I got this on basically one of the lower settings. Okay, I increased the speed. I think I'm up to about 700 or 800 now. Get us a measurement. Looks like 40.02. Let's go just a little bit farther. I'm just going to take a real light cut going back and forth. Alright, that's about 39.5. That's fine. That'll work. Like I said, this is not a critical measurement. It's just got to be within under 40 millimeter. Pull this out a little bit and we'll see what it looks like. What's that double boost always says? Take your cutter out or retract it out of the way. That's the reason. Yeah, let's not do that. Alright, so that's going to go out like that. And this block is going to go in here. Like so. There we go. Just like that. So that takes up that gap. It's a nice solid block to mount off of. And that'll work. So okay guys, I'm going to end it here for today. Next time we're going to drill the holes in the block. And then we're going to take the top of the compound off completely, and we'll drill and tap it for the screws that'll hold our scale here. So anyway guys, I hope you enjoyed that. Somebody had mentioned that I don't do a lot of milling on this thing, and that's true. It's not because I don't want to or I don't think it can do it. It's just because I don't do a lot of milling. About 95% of what I do is on the lathe. So it certainly will mill. As you can see, it's not the most pretty thing in the world, but it gets the job done. It's square, it's flat, it's, you know, very nice. They do work. This machine does work better with roughing in mills, I will say that. But I wanted to give this one a shot. This is a mill that I bought. It's specifically for aluminum. And it does a decent job, as you can see. Now, as probably most of you know, this is actually flat. It just looks that way because of the cut. And then this side, this is the side I should have gone back across this side and climb milled it, because that gives you a little bit better finish like this one, a little more consistent finish. But that doesn't matter, because something else I want to do next time is I want to make this a little prettier. I'm a big believer in if you're going to do something like this, if you're going to make something like this, put a little bit of personality into it. And that's sort of a Victorian mindset, I think, but it just makes it a little different. So we won't do anything drastic or anything. I'm thinking, well, I'll save that for next time. Anyways, guys, thanks for watching. I hope you enjoyed a little bit of milling. And we'll see you next time. Bye.